Welcome to ISPFL6 Object-Oriented Programming. Inheritance. Inheritance is one of the core concepts of object-oriented programming languages. It is a mechanism where you can derive a class from another class for a hierarchy of classes that share a set of attributes and methods. Inheritance can be defined as the process where one class acquires the properties, which is the methods and fields of another. With the use of inheritance in the information, it is made manageable in a hierarchical order. The class which inherits the properties of other is known as subclass, or sometimes derived class or child class. And the class whose properties are inherited is known as superclass, or base class, or parent class. Inheritance is the ability of a subclass to take on the general properties of superclasses in the inheritance chain. The properties then form part of the subclass definition. Inheritance enables superclasses' properties to be propagated downward to the subclasses in a class hierarchy, and makes the properties available as part of the subclass's definition. These properties are said to be inherited or taken on by the subclasses. Using inheritance, the salesperson's class of figure 6.1 can now be defined by a combination of properties from the employee class, the person class, and its own specific attribute and method definition. Figure 6.3 shows the modified class hierarchy with inherited properties highlighted in bold. The information in the extended hierarchy suggests that all employees have a basic salary except managers and salespersons, who are paid on allowance and commission respectively. Code reuse. Code reuse is the practice of using existing code for a new function or software. But in order to reuse code, that code needs to be high quality, and that means it should be safe, secure, and reliable. By allowing information of a superclass to be taken on by subclasses, the information is said to be reused at the subclass level. All newly created instances of the subclasses would have as part of their definition the inherited information. Employee number, basic salary, and get employee number of the employee class, and name and get name of the person class are said to be reused by the manager and secretary class. When can you reuse code? Number 1, easily extended and adapted for the new application. 2, ported to different hardware if needed. And 3, shown to be free from defects or problems that affect the reliability, safety, or security of the new application. In an ideal environment, a developer would be able to access stable and trusted code libraries. They'd then be able to reuse code from those libraries as building blocks within their application. But the environment is not always ideal, and code doesn't always fulfill these requirements. So, reusing code often sounds much easier than it is. Making changes in class hierarchy. There are 3. Change in property definition for all subclasses, change in property definition for some subclasses, and adding or deleting a class. Changes to software specifications are inevitable. Let us consider how changes in a class hierarchy impact software maintenance as a whole. Change in property definition for all subclasses. Number 1, inheritance is not available. And number 2, inheritance is available. Suppose a change in representational scheme of the employee number is required. This change will affect not only the attribute employee number, but also the method getEmployeeNumber and possibly other classes that inherit employee number. We will examine this change in two possibilities. It could be in a form of inheritance which is not available and an inheritance which is available. Inheritance is not available. In the case where inheritance is not available, the attribute employee number and method getEmployeeNumber would have to be defined in all the relevant classes. For example, employee, manager, salesperson, and secretary. The change in representational scheme of employee number would thus have to be effected individually on these classes. The redundancy arising from the multiple definition of employee number and getEmployeeNumber may lead to inconsistency in definition if the change is not carried out properly. Inheritance is available. With inheritance, the situation is different. We would first define attribute employee number and method, which is getEmployeeNumber, in employee class and let subclasses manager, salesperson, and secretary inherit these definitions from employee class. The required change in representational scheme for attribute employee number would be limited to the employee class. The change would be propagated to the subclasses via inheritance. In this way, the change is thus limited to the superclass, enabling a uniform and consistent property definition for all subclasses. In addition, redundancy in property definition at the subclass level can be minimized and software maintenance enhanced. Change in property definition for some subclasses. A change in property definition at the superclass level may not necessarily apply to all subclasses. Classes in Java exist in a hierarchy. A class in Java can be declared as a subclass of another class using the extends keyword. A subclass inherits variables and methods from its superclass and can use them as if they were declared within the subclass itself. Adding or deleting a class. Adding a class into an existing class hierarchy can be detrimental to the stability of the hierarchy. It is always recommended that the addition of a new class be created as a subclass in the class hierarchy. The definition of existing classes will not be adversely affected by this approach. To illustrate, let us consider an example of geometrical shapes. In Figure 6.7 is a class hierarchy of shapes. Shape is a generalized class of circle and square. All shapes have a name and a measurement by which the area of the shape is calculated. The attribute name and method getName are defined as properties of shape. Circle and square, being subclasses of shape, inherit these properties. Note that the attribute name is declared as private in the shape class. To make it known to other objects, a getName method is defined in the shape class to return the value of attribute name. Inheritance chain. The path of inheritance over the class is known as the inheritance chain. A single inheritance chain can be single or multi-level. In a single-level, single inheritance chain, there is only one level of superclass that a subclass can inherit properties from. In contrast, in a multi-level single inheritance chain, a subclass can inherit from more than one level of superclasses. The difference is illustrated in Figure 6.9. Besides single inheritance, there is also multiple inheritance. A class hierarchy is said to exhibit multiple inheritance if a subclass in the hierarchy inherits properties from two or more superclasses in more than one inheritance path. Multiple inheritance. Multiple inheritance is a feature of object-oriented computer programming languages in which an object or class can inherit characteristics and features from more than one parent object or parent class. To appreciate the concept of multiple inheritance, let us consider the example of frogs. A frog is an amphibian that takes on characteristics typical of a land animal and a water animal. A frog can live both on land and in water. We can thus represent frogs as instances of a frog class and specialize it is a subclass of land animal class and water animal class. The frog class will inherit from the land animal class the ability to live on land, and from the water animal class the ability to survive in water. Figure 6.10 shows the position of the frog class in relation to its superclasses in a class hierarchy. By inheriting properties from more than one superclass, the frog class is said to exhibit multiple inheritance. All properties of the land animal and water animal classes are now part of the definition of the frog class. Interface. An interface is a reference type in Java. It is similar to class. It is a collection of abstract methods. A class implements an interface, thereby inheriting the abstract methods of the interface. Along with abstract methods, an interface may also contain constants, default methods, static methods, and nested types. Method bodies exist only for default methods and static methods. Writing an interface is similar to writing a class, but a class describes the attributes and behaviors of an object, and an interface contains the behaviors that a class implements. Unless the class that implements the interface is abstract, all the methods of the interface need to be defined in the class. An interface is similar to a class in the following ways. An interface can contain any number of methods. An interface is written in a file with a .java extension with the name of the interface matching the name of the file. The bytecode of an interface appears in a .class file. Interfaces appear in packages, and their corresponding bytecode must be in a directory structure that matches the package name. An interface is similar to a class in the following ways. You cannot instantiate an interface. An interface does not contain any constructors. All of the methods in an interface are abstract. An interface cannot contain instance fields. The only fields that can appear in an interface must be declared both static and final. An interface is not extended by a class. It is implemented by a class. An interface can extend multiple interfaces. Declaring interfaces. The interface keyword is used to declare an interface. Here is a simple example to declare an interface. So we have here the import java.lang. We need to be able to have an interface which is declared as public interface or name of interface. Interfaces have the following properties. An interface is implicitly abstract. You do not need to use the abstract keyword while declaring an interface. Each method in an interface is also implicitly abstract, so the abstract keyword is not needed. Methods in an interface are implicitly public. So this is an example of how you code the interface to Java. So we have here animal.java. We declare the keyword interface, then the name of the interface. Then we'll be able to declare the public void it and the public void travel. Implementing the interfaces. A class uses the implements keyword to implement an interface. The implements keyword appears in the class declaration following the extend portion of the declaration. So in this example, the code will produce the result of the mammal eats and mammal travels. So these are the different content of our interface animal. Extending multiple interfaces. A Java class can only extend one parent class. Multiple inheritance is not allowed. Interfaces are not classes. However, and an interface can extend more than one parent interface. The extends keyword is used once, and the parent interfaces are declared in a comma-separated list. So for example, we have public interface hockey extends sports and events.